Good afternoon or good morning, depending on where you're watching us from. There are people in the western part of the globe who, in which they're waking up right now. But for us here in Kenya and Africa, good afternoon. So this is our lesson. Most of you had seen it. Most of you have been invited. And I'm glad that you have actually joined us today. So we are going to study about the structure of the atom and the periodic table. We learn about how to write chemical formulas, how to write chemical equations, how to calculate the relative atomic mass, how ions are formed from atoms, and which we are going to discuss on the way. Kama kawaida, I'm glad that already as we are starting the lesson, there are members who have already joined us and they're already in class. I just want you to tell me, how is my audio? Can you hear me very well? Are you struggling to hear me? Nataka work on it. My engineer can talk on the same, and if you can hear me, just mention one thing. Say you are loud. Can you hear me? I'm waiting for you to type that. So today we are going to see the structure of the atom and the periodic table. Structure of the atom. Structure of the atom. Timothy Munga, thank you for confirming that you can hear me. Hi, Juliet, how are you? We are discussing structure of the atom and the periodic table. But for now, allow me to deal with the structure of the atom. Structure of the atom, then we will see and check on the periodic later on. Thank you so much. So when we talk about the structure of the atom, I'm telling you about the perception in which we are supposed to tell you about the structure of the atom. Atoms are the smallest particles of an element. And we are going to perceive an atom to be a circular in shape, this way. And atom has two parts. And these two parts is, we have the inner part, like a cell. Those who learn biology in Form 1, you know about a cell. It has a nucleus in it. Even an atom, it has a nucleus. The part, so this one is called nucleus. Nucleus. Then, outside the nucleus, we have what we call atomic. Okay, let's call it energy levels. Let's not call it atomic levels. Let's call it energy levels. Yes, that one. Let's call it energy levels. So energy levels can be 1, can be 2, can be 3, can be 4, can be 5, can be 6, depending on the size of the atom, depending on what we call atomic number. Now, there are 3 subatomic particles. What do I mean when I say subatomic particles? Inside the atom, we have 3 other atomic. Because they are found inside the atom, we call them subatomic particles. Subatomic particles. And there are 3 in number. 1, can you type there subatomic particles? 1, we have neutron. 2, we have proton. Then 3, we have electron. These 3 are called subatomic particles. My next concept is, where are these subatomic particles found? Where are they found? Where are they found? Yeah, where are they found? Because we only have 2 parts of the atom. We have the energy levels part, then we have the nucleus part. Where are these subatomic particles found? They are found, let me now put it. I can clear this for you so that you can see it. Now, of the 3 inside the nucleus, those 2 are neutron, electrons found. It is found in the energy levels. It is found in the energy levels. Are we together up to that point? Are we doing well? Tunaendelea vizuri? So they are found in the electrons are found in the energy levels. Thank you for those who are in and they are confirming that they can hear me very well. We are moving on with our lesson. We have Paul Mosetti. Anasema, I can hear you. Thank you. We have the teacher for mathematics and chemistry. Anasema, very clear. My students will check on you later on. We have Juliet. Anasema, I can hear you. Then we have Evans Nyambane. Thank you for confirming that together with Esther. Anasema, yes, we can. And Timothy was the first person to comment on that. So let's move on. Now, in these three subatomic particles, I want us to say this. You know, we have charges, positive charges and negative charges. So let me assign this. Let me assign charges to the subatomic particles. Now, to answer protons. Protons are positive. Electrons are negative, or simply negatively charged. Neutron are neutral. The meaning of the word neutral in a mentioning, neutral. When we say it is, they are neutral. What does that mean? Neutral in a manner, it has no charge. Are you together? Neutral means it has no charge. Now, so meaning we are going to talk on this, but basically, most of the topic or most part of the topic, we shall be only talking about protons and electrons. We shall always be talking about protons and electrons. Rarely are we going to talk about neutrons. You know, they are neutral and they don't participate so much in what we are going to talk about, the reaction. But padai kidogo, yes, I will tell you how it participates, especially when we learn chemistry form 4. By the way, after this, sijui kama tunarudi discuss chemistry form 1. Yeah, tunarudi form 1 kidogo tu, but from now ndakuwa natwanga chemistry form 2, form 3, hivyo tukisonga mengi. Angela Nzama, thank you for taking your time to teach us. I'm grateful, Angela, and I'm humbled. Now, kuna hizi mbili nilisema inapatikana ndani ya nucleus, and that is the neutron and protons. What is a collective name given to neutrons and protons? The two of them are found inside. Where? The nucleus. So what is a collective name given to the both of neutron and proton? As we're moving on, somebody to tell us the collective name, one name that refers to both neutrons and protons, ni nini? Tuambie. Yes. So now, I'm waiting for you. Yes, I'm waiting for you so that I can discuss something else. What is a collective name given to both neutrons and protons? Let me clean the board because I want to deal with something else. What is the collective name given to both neutrons and protons? Somebody has given me the answer, which is very, very correct. It is called nucleons. Nucleons. Nucleons refers to both protons and neutrons. Sawa sawa. Kama ni mara yako ya kwanza kusikia hiyo statement, at least furahi leo umesikia the meaning of the word nucleons. Yes. So I want us to define the following two terms: atomic number and mass number. Atomic number and mass number. Atomic number and mass number. In the meantime, can you be typing there what is atomic number? And then what is mass number? Atomic number and mass number. Atomic number and mass number. So if we are with you in any WhatsApp group, can you tell them the lesson is going on very well so that they can also join us and benefit from our lesson? Tell them Sir Alex is there waiting for you. Wewe Emi, unapoteanga sana. Unakuja leo You are coming once per week. So umekuja ya hii wiki. So next week yote sitakuona. So if you are in any WhatsApp group with your friends, I kindly request you, tell them to join us. In the meantime, what is atomic number? What is mass number? Now, elements, listen to this as you are typing for me what atomic numbers and mass numbers are. Elements have been arranged depending on what we call the number of electrons. Sawa sawa? Elements have been arranged depending on the number of electrons. An element with one electron is said to be having atomic number 1. An element with 2 electrons is said to be having atomic number 2. An element with 3 electrons is said to be having atomic number 3. An element like calcium with 20 electrons is said to be having atomic number 20. Sawa sawa. Now, we've started by talking about protons, neutrons, and electrons. Sasa, for those 3, for any given atom, hakuna class ya Google Meet, Amy. We are, from now going forward, all our classes are done on YouTube. I will be giving you the 3 YouTube channels that we are live streaming on at the end of the lesson. So keep on with me. Now, I'm saying this. Protons of any given atom are always equal to electrons. Always. If a certain atom has 12 electrons, it also has 12 protons. They are always equal. Are you to get up to that point? They are always equal. Yeah. Now, atomic number refers to the number of protons in an atom. Atomic number refers to the number of protons in an atom. Can you hear me? It refers to the number of protons in an atom. What about mass number? Kumbuka kuna kitu fulani hapa tuja mention, kuna kitu inaitwa neutron. Now, if you add protons of a given atom plus its neutrons, it gives us mass number. So basically, what is mass number? Mass number is the sum of the protons and neutrons of an atom. That's the mass number. I hope we've gone to invite other people. So, atomic number refers to the number of protons in an atom. Let me challenge you. I don't know whether you are ready to be challenged. Can I challenge you? Can you say yes? I want to challenge you. You fear challenge. Until I say yes, I will not challenge you. Because nataka kuwaje. Kuna tu swali kidogo hapa. Before nifute hii niende kitu ingine. Kuna kitu tu kidogo. I want to challenge you. I'm waiting for Juliet and Nyambi. Yes, challenge me. So that I can proceed to challenge you. Basing on the definition of atomic number and the definition of the mass number and, protons and neutrons. Now, if must you say in an atom? Yes, we have to say in an atom. We have to say in an atom. Angela, why we have to say in an atom? Now, my challenge is this. Get ready? Somebody was saying, are you ready for Tuesday? Yes, I'm ready for Tuesday. Now, we are saying that in a given atom, the protons are always equal to the electrons. Yani, siko sawa. They are the same. Kama ni 12 ni 12. But now, hapa juu, tumesema atomic number refers to the number of protons in an atom. why not number of electrons? Yet hapa chini nimesema they are equal. Why? What can you say about that? Why are we restricting the definition of atomic number to be there? It refers to the number of protons. Why not electrons? Yet here we are saying protons and electrons are equal. What can you say? If you can answer me that, then we can proceed. In the meantime, allow me, I want to continue, but make sure you give me that particular challenge. Yes. But before nifute atomic number na mass number, kuna kitu nataka kuelezea. Have you ever heard of subscript and superscript? Kama uko na mtu hapo kando yako muulize, unajua kuhusu subscript and superscript? Subscript and superscript. What is a subscript and what is a superscript? Sawa sawa. Super and subscript. Those two nataka leo tujue ndio tuendelee. Now, by the way, ameniambia, where are you watching me from? You are watching me while I'm in Limuru. So I'm asking, where are you yourself watching me from? Watu wa Limuru mko hapa ndani? You can tell me. Let me use this element. Let me use an element like, I told you anytime I want to use an example of an element, I always go to sodium. I don't know why. I don't know. So sodium is position 11, and footballers in the field are 11, and I love football. Is that the symbol for sodium? Is that the symbol for sodium? Can you say yes? Now, if you're told, being provided with the symbol for any element, and you've been given the atomic number and the mass number of that particular element, the mass number, the atomic number should be seen in that particular element. So, kuna kitu inaitwa superscript. Then we have subscript. Kwa hiyo niandike hivi. Yeah. What am I even writing? Superscript, then subscript. What is the mass number of sodium? I say its mass number is the sum of protons, which is 11, plus the sum of neutrons. Sodium has 12, so only 23. The atomic number, of course, it is 11. Now, this one, which is 23, you are supposed to show it as a superscript. Superscript inamaanisha inaandikwa juu ya element this manner. Wacha niandike hapa. If this is sodium, tutaandika hapa 23, 11. Anybody with common sense, ama mwenye amepitia a chemistry class like you, will know 23 enye imeandikwa juu as a superscript. It is the mass number. Enye imeandikwa chini yake, it is the atomic number. Have you gotten something there? Have you gotten something from what I've just said? About superscript and subscript? Yes. Let me proceed. Now, the next part is this. I know your teacher challenged you. Akakwambia hivi, for us to proceed with the topic, you must have mastered the first 20 elements. I'm praying to God that you really know the first 20 elements. Bila kustruggle. Are we together? Are we together? The first, hata kama ni kuimba, please sing until you get the first 20 elements. Nataka tu nikisema number 17, akili inajua ni chlorine. Nikisema number 11, unajua ni sodium. Nikisema number 6, it's carbon. Nikisema number, whatever the number I've mentioned, the first 20. It is a requirement. Why? Okay, I'm going to read for you the first 20, and I hope you know them. So I'm saying this, why we don't define atomic number using the electrons, but we use protons, is because anytime electrons can be lost or gained. So we are using protons because they are ever constant. Sio umeshika? Protons are ever constant. Protons can never be lost or gained. Electrons can be lost. Electrons can be gained. Can you say amen? Mpaka hapo tuko sawa? Yes. Now, so the first member is called hydrogen, followed by helium, lithium, beryllium, boron. Are you together? Followed by carbon, nitrogen, oxygen, fluorine, and neon. Those are the first 10. Number 11, sodium, magnesium, aluminium. Those are the first, those are the metals. Number 11, 12, and 13. Number 13 is aluminium. Number 14 is called silicon. So, sulfur, it's a yellow non-metal. Then number 17, we have chlorine. 18, we have argon. 19, we have potassium. And 20, we have calcium. Are we together? What is a special name? Let me ask a question. Let me take you to number... Let me take you to number 14. Tumesema na number 14 nini? Please tell me. Tulisema number 14 What is the element with atomic number 14? There's a question I want to ask about that particular element. And number 6. But basically number 14. Tulisema number 14 I'm waiting for you. Number 14. Tulisema number 14 is silicon. Mosetti has answered it very well. Now, silicon, ebu sikia hivi vizuri sasa. Unajua mimi tunawapea terms zingine yenye maybe amtaangalia. Silicon, is it a metal or a non-metal? That's my question. While I'm cleaning the board, niambie kama silicon ni metal ama non-metal. Wewe jiulize, silicon ni metal ama ni non-metal? Is silicon a metal or a non-metal? Kuna wale wamejikomit wamesema non-metal. Kina Amy from Kibiringia. Umesema uko wapi? Kaplelak Kibiringia. Sawa, mimi sijui uko ni wapi. Kuna mtu ndampea high five. Sijui kama chatbox ya YouTube iko na high five kweli? Aina? Nilitaka kuna mtu amejibu, kuna watu wamejibu swali vizuri hapo. The lights of Esther, Beverly, Bernard. Yes. Silicon is a metalloid. Metalloid. What do you understand by the term metalloid? Metalloid. What do you understand by the term metalloid? An example of a metalloid is silicon. An example of a metalloid is silicon. Are you together? Now, a metalloid is an element whose properties are found in between those of a metal and a non-metal. It can be a metal, saa zingine ni non-metal. Its properties are found between those of a metal and non-metals. Hapo umeshika, si ndio? Kama umeshika ni fiti sana. So, as we are proceeding, the first challenge I'm giving you, especially those who are in Form 1 who will be going to Form 2 next year. My friends, kama kina Beverly, they already know the first 20 elements. They don't guess. They know what they are saying. And because they know, they are well with that. They are well with that. So, wewe mwenye unaingia Form 2 ama umeingia Form 2, I know maybe the teachers, when they were teaching this topic, they rushed because of time and, here and there. So, kuna vitu mingi utashika. Make sure umeishika. Before ulale leo, make sure you know the first 20 elements. And together with their mass numbers, atomic numbers, all those. Juliet anasema pardon. Please repeat. I'm saying this. A metalloid is an element whose properties are found in between the one for the metal and the one for the non-metal. For example, we all know that metals lose electrons. The electronic configuration, though asitafika hapo lakini bado ndafika hapo. The electronic configuration of sodium is 281. It is going to lose how many? 1 to form ions. For silicon, it is 2, 8, 4. So it can either lose 4 or gain 4 to be stable. So what do we mean here? It can gain like non-metals. It can lose like metals. It's a metalloid. Did you hear me? So nani Moseti and Juliet, si umeshika hiyo? Aya, allow me now to proceed. Allow me to proceed. Let me see what the other, if someone is asking question in the other channel. No, okay, sawa, no problem. So now wale mnaingia sasa mtuambie, why are you coming late? Why are you coming late? Why are you coming late? Now, anyway, sasa nitakuchapa acha na wewe uko mbali. Now, we are defining the term isotope. Isotope. Can you say isotope? We are defining the term isotope. Isotope. We are defining this term isotope. Kama, as I'm still explaining, you can be typing what is isotope. And those who are in Form 2 going to Form 3, or those who are in Form 3 already, you know some of the terms which wanafunzi wana confuse na isotope. Mnajua allotrope. Allotrope iko kwa carbon and its compound. Unaambia tu mwanafunzi vizuri, define for me isotope. Yeye anaenda ahead na ana define nini? Allotrope. Na anatembea hivi. Ati naweza anguka maswali yote lakini hiyo siwezi anguka. Kumbe hiyo ndio ameanguka. Wachana nayo. Then kuna ingine form 3. Any form 3 around? Kuna kitu inaitwa isomer. These terms. Anyway, today we are dealing with isotope. Allotrope will come later, but I will still define all of them so that in case we have any form 3 around, asikuwa na confuse hizi vitu tatu. Isotope, allotrope and isomer. Lakini mimi naona ni kama mngenisaidia kudefine isotope. Beverly Alana akiwa na Bernard Mwai, ungenisaidia kudefine allotrope. Then Amy mwenye anasema yako form 3, ungenisaidia kudefine isomer. At least mimi tu kazi yangu ikuwe rahisi. I just nione kama umedefine vizuri. So we are starting with the term isomer. What are you saying? What are you saying about isomer? What are you saying about isomer? What are you saying about allotrope? And what are you saying about isotope? Sawa, I want to hear from I hope you are in class. I want to mention you. What is your name now? Anaitwa Wahome, Regan Wahome. Yes, Regan Wahome from Thika High. Are you in class? Regan Wahome, are you in class? If you're in class, say yes. Wewe Amy ningekuwa na wewe ningekutwanga. But haina shida. Waja nisikutwange. Now, let me define the term isotope. Because, oh yes, Timothy is in class. Let me define the term isotope. Can you say this? These are atoms of the same element, having the same atomic number, but different mass numbers. Atoms of the same element, having the same atomic number but different mass numbers. I'm going to dwell on isotope because it is found in the today's topic. Hii allotrope, we will discuss it in carbon and its compound, the last topic of Form 2. Isomer, we are going to discuss it when we shall be dealing with organic chemistry 1 and 2. Now, before I wrap allotropes, because I'm going to wrap it, it's not part of our discussion today, but allow me to just mention and say something on the same, that allotrope, these are they have the same atomic number but a different mass number. Sawa. Allotrope, these are elements which they have the same, they're in the same physical state but a different appearance. The example here, allotropes, is diamond and graphite. Different appearance, the same physical state. Isomer, they have the same molecular formula but different structural formula. Mnashangaa nasema nini? Hiyo mkifika hiyo time tutayangalia. So allow me to remove this. It's not part of our today's lesson. It's not part of our today's lesson. Now, let's talk with isotopes. Atoms of the same element with the same atomic number but different mass number. Sawa? Mtu akipiringia. But ni sawa tu. Ni sawa tu mtu akipiringia. Beverly anasema isotope are atoms that have the same atomic number but different mass number. Thank you kabisa Beverly. That is how to define it. For example, let me use chlorine. Chlorine, by the way, it exists as isotopes. Why? We have chlorine mara mbili. Sote ziko na 17 as the atomic number. Sote ziko na 17 as the atomic number. Lakini sasa mass number, ingine iko na 35, ingine iko na 37. Ingine iko na 35, ingine iko na 37. So the big question is, why? Yet they are of the same element. They simply have different mass numbers, but the same atomic numbers. So these two are said to be, isotopes. They are said to be isotopes. They are said to be isotopes. Are we together? Now, let me give you a question. Kuna hii ya kwanza, just to look on the board. Kuna hii ya kwanza hii. Kuna hii chlorine ya kwanza. Let me name this as 1. I name this as 2. Give me the number of neutrons of chlorine number 1 and give me the number of neutrons of chlorine number 2. That 5 is mass number. This that 5 is the mass number. That 7 is the mass number. Tumesema they have the same atomic number but different mass numbers. Amy. But it's a good thing. It's good to ask that way, so that wenye hawapo wanajua wajue. So I'm asking, give me the number of neutrons ya hii. Give me the number of neutrons ya hii. By the way, what brings about the differences is the number of neutrons. So unajua mass number is given by protons plus neutrons. Now atomic number is just like the number of protons, these ones. So can you get the number of neutrons this chlorine and this chlorine? Esther amesema 18 and 20. We shall check on that, Esther, if you are correct. And then if you are indeed correct. To you is, when you join a lesson, stay in that lesson up to the end. At least tomorrow. And by the way, nimeamua hii wiki tunatuanga physics, ndarudia physics next week. But for this week, we shall be dealing with chemistry for the remaining number of days. Tomorrow tutamaliza hii topic kama tutamaliza leo. Friday tutaingia, we shall just be discussing chemistry. So to get the number of neutrons here, sema 35 minus 17. Or to get 35 minus 17, you get 18. So the number of neutrons here is 18, meaning Esther was correct. Who else? Amy is also correct. Eunice Ndinda, you are also correct. Beverly, you are also correct. The other one, 37 minus 17, you will get 20. So the number of neutrons here is 20, the number of neutrons here is 18. Can you clap for yourself for doing that question? Kama umejaribu vizuri ya swali, clap for yourself. Clap for yourself. So that is the meaning of the word isotope. That's the meaning of the word isotope. Now, niko na swali. Nishafunza hiyo swali lakini wacha niulize sasa ndio nikisahau nikuwe safe kidogo. Atom is said to be electrically neutral. Atom is said to be electrically neutral. How is that possible? Explain. It is said to be electrically neutral. Tuambie mbona atom is said to be electrically neutral. Is said to be electrically neutral. Uliambiwa ni kwa nini? Unajua Amy ananiambia ati mwalimu wangu alinifunza hivyo. Sasa mimi najua si mwalimu wako alikufunza hivyo. Hiyo time mwalimu akifunza wewe ulikuwa umeenda choo. Sasa ukafika wengine washafunzwa. So unataka kublame mwalimu na wewe ulitoka ukaenda washroom. Time mwalimu anafunza. Why is atom said to be electrically neutral? Yes. And why is atom said to be electrically neutral? No one knows why atom is electrically neutral. For sure you want to tell me hiyo nayo mjui hapa na inafaa mkwe mnajua. An atom is said to be electrically neutral. Can you explain? Okay, if you are told hiyo swali ukijibu utaenda America. Unataka kuniambia uwezi jibu? Sawa. I will answer you that because sijui mbona hata nimeanza kuuliza hiyo swali. Hiyo ni shida tu yenye nimejeletea mwenyewe kwanza kuuliza swali na nyinyi wenyewe hamtaki kunijibu hiyo swali. Look here. Kwanza, do you want me to answer that question? Pengine ni mimi nataka kujibu maswali zangu. Do you want me to answer that question? Why atom is said to be electrically neutral? Can I answer it? Na kuna swali ya isotope nataka kuwapea. So nauliza, do I really need to answer that one? Lakini calculation question ndawawekea nyuma kidogo. So atom is said to be electrically neutral because the number of protons which are positively charged are equal to the number of electrons which are negatively charged. So the effect cancels out. Can I repeat? The number of protons which are positively charged are always equal to the number of electrons which are negatively charged. So the effect cancels out. Esther, umepata hiyo swali. Naona umejibu hapo. Now, it's like, when then 6 protons. E ni negative charges, E ni positive. So the effect cancels out. So it becomes neutral, electrically neutral. But ion, sikia hapa, ion is not neutral. Ion can either be positively or negatively charged. So hiyo inafaa ujue vizuri. Yes. Hapo si tuko sawa? Kuna mtu ako na swali? Aya, nataka tuingie kitu inaitwa electronic configuration. Electronic arrangement. Another, somebody can say configuration. How to configure electrons, electronic configurations. Yes. Yeah, that is it. Can you see what I'm writing on the board? Madhenge, can you see what I'm writing on the board? Ndaka ikue inaonekana, you can read what I'm writing on the board. Electronic configuration. That is what I want to discuss for the next 10 minutes. Electronic configuration. And I would like you to just follow me very well. We said the challenge that we are giving each other is, when you join a lesson, stick to that lesson to the end. Hii maneno ya unaingia kidogo, umetoka, umeenda, wachana nayo. Sawa. So electronic configuration is how the electrons are arranged in various energy levels. I said this at the beginning of the lesson, that we have two parts of an atom. We have the inner part called nucleus, then we have the outer part called energy levels. The energy levels can be 1, can be 2, can be 3, can be 4, can be 5, depending on how many electrons. The more the electrons in that given atom, the more the energy levels. And it has a rule. The first rule is the next energy level is occupied by 8. The next is 8, Evo. 2888. But inafikanga mahali, hii sitawafunza, lakini inafikanga mahali, we focus. Because ikishakuwa mingi, kuandika 888, tunaenda 2881818. Hiyo ni baadaye. Hiyo sio high school. Lakini if you can develop interest in chemistry, like I developed interest in chemistry, tukiwa campus, we did that when we were, it's just like this, but we are changing our rules kidogo tu. Hiyo ni baadaye. Hakuna haja niwafunze sana, some of you want to be lawyers. Unajua sasa kama unataka kuwa lawyer, sitaki nikusumbue sana, tukae tu na chemistry ya high school. Ama namna gani? Si ni namna hiyo. So what I can say is this: stick to the rule of 2, 8, 8. I mean, just to know how to show the electronic arrangement of the first 20 elements. Wewe chua ukikaa hivi, the first energy level is occupied by 2, the rest 8. Are you getting me? Amy is saying that you are breaking. How is that? Let me get 2, 3 people are saying they can hear me very well. Tuendelee. I want to show you something on electronic arrangement, but confirm you can hear me. I'm waiting for 2 people to tell me you can hear me. Can you hear me? Timothy, niambie. So now, as I'm waiting that you give me or you let me know is that niliwaambia the perception is the atom is said to be circular. Sometimes when we see them through the very powerful electronic microscope, which is not available in our school, they may not be circular. Lakini sasa for the clarity and the neatness of drawings, we make it circular. Inside here, we have energy levels. Inside here we have nucleus. Inside the nucleus, we have protons and neutrons. So make sure you show us the number of protons and neutrons in that particular atom that you want to show the energy levels. For example, let me use magnesium. For example, let me use magnesium. I will only draw for 3 atoms. In those 3 atoms, for sure, utakuwa umejua kenye namaanisha, utakuwa umejua how to give electronic configuration. Magnesium has atomic number of 12. It has atomic number of 12. So if it has atomic number of 12, angalia hapa everybody, if it has atomic number of 12, let's distribute. By the way, the process of distributing the electrons to various energy levels is called electronic arrangement or electronic configurations. Let's configure these 12. Let's configure these 12. Take 2 to occupy the first energy level. You separate using a dot. 2 is 2. Next is 8. Sawa sawa. 2 plus 8 ni 10. Imebaki ngapi from 12? Imebaki 2. Weka hiyo 2 hapa. Sawa sawa. Ingekuwa, let me pick another element like argon. Did you say it's called argon or argon? Argon, number 18. If we have to distribute these 18 electrons, chukua 2, ichukue the first energy level, chukua 8, ichukue another energy level. Then as you are doing so, make sure you have in mind how many are remaining. 2, 8. Ndio icha 18, 2 plus 8 ni 10. 288. In 282. So meaning, this one will take the first energy level, second energy level, fourth energy, first, second, and third. And for argon, you can realize that all of them are full. The first one is complete with 2, the second one is complete with 8, the third one is complete with 8. For magnesium, the first one is complete, the second one is full, the third one is not, because it's only having 2, and it's supposed to be having how many? It's supposed to be having 8, so it's not complete. But it will occupy the third energy level. Sasa, kama ni kudeal na let me start with magnesium. Iko na 3 energy levels. So sasa, first of all, let me use this one. I must draw a big nucleus, whereby in that big nucleus, I must show the number of protons and neutrons inside the nucleus. So, how many protons does magnesium have? 12. Dandika 12p. How many neutrons? Still 12. 12n. So, mtu mwenye ameenda shule kama wewe, na wewe mwenzako, na wewe mwingine, na wewe mwingine, ikiandikwa hivyo anajua 12 protons, 12 neutrons. Then, unaweka energy level hivi. So, we have this first energy level. This is the first energy level. Inachukua ngapi? 2. These 2. Hii 2. Next energy level inachukua 8. So they are always moving in pairs. Always in pairs. In partners. In pairs this way. Then we are only remaining with 2. E for 2. That's a electronic configuration of magnesium. Hapo chameni kuna kitu ngumu? Unless wewe ndio mgumu. Hapo kuna kitu ngumu kweli? Yes. Hiyo iko sawa kabisa. That is very well. Nataka tuende ingine. Nimewaambia I will only do 3 examples. After doing those 3 examples, si utachua ingine. Nataka tufanya sulfur. So before you do for sulfur, kitu ya kwanza lazima ujiambie ni what is the atomic number of sulfur. What is the atomic number of sulfur? I will tell you it is 16. So let's distribute these 16 electrons. Itakuwa 2 for the first energy level, 8 for the second energy level, then 6 for the third energy level. Hii ukiati inakupa ngapi? 16. So let's go there. We draw one for sulfur. So we will have 16p Sindilambe lazima uandike then 16n. Then we have the first two, these ones. Then the next ni 8. 1 2 1 2 1 2 1 2 1 2 1 2 1 2 1 2. Hiyo ni 8. So tumepangisha another energy level. Allow me to wrap this. Itusaidii for now. Ni kama wale watu hawacha join lesson. For now hawajisaidii. Na nimesema let's make it a compulsory that everybody to join. So here we have 6. So ndaweka hapa 2, niweka hapa 2, niweka hapa 2. Usijaribu kupeana more than. So angalia, my first energy level this one iko tu na 2 electrons. Si ndio hii tu. The second energy level iko na 8. 1 2 3 4 times 2 8. The other one iko na 1 2 3 6. Ndio hii. Tuko pamoja. Boys and girls. Are you moving together? Kama utaki kutumia crosses to show electronic configuration, you can use dot. But for me, I find dot taking a lot of time. Kitambo ufanye hivi, si ufanye tu hivi. But chaguo ni lako. Chaguo ni lako. Niwe ndio utaamua venye unataka. Sawa sawa. Aya, tufanye ya lithium. Lithium. Let's do for lithium. First of all, hebu mniambie lithium ni what's the atomic number for lithium? Ndaka tu mniambie because siwezi nikawaambia how I cannot ask you to draw for me because sijui kenye unafanya, lakini nataka tu mahali huko. Just type there, what is the atomic number of lithium? Boys and girls. Na wangoja tu mniambie what is the atomic number of lithium ndio tuendelee. It is 3. Yes. Bernard Mwai, umewai. It is 3. Sawa sawa. So wacha tufanye lithium then tuachie hapo tuende kitu kingine. Wacha niangalie time. Oh, it's already 4. Niliwaipia how many minutes. I was supposed to start at exactly 3, nikaanza some minutes after 3. So bado tunasukuma kidogo some minutes after 4. Bado kumbuka kesho tutakuwa tunaendelea mahali tuliachia. Hapo ndio tutakuwa tukiendelea. So don't worry about that. I want us to do for lithium. Lithium iko na atomic number 3. Electronic configuration is 2:1. So nikichora kwanza hivi 3p4n na maana iko na neutrons ngapi? Neutrons 4. Then kuna watu wanataka dot. So ndaweka hapa 2 hivi. Ama weke xx, no problem. Then the next energy level iko tu na kamoja peke yake. E for 2. Imagine E for 2. Sawa sawa. Kuna mtu akona swali before I say something. Before I give what we call closing remarks. Kuna mtu akona swali. Tomorrow we shall be talking about the periodic table, the RAM, chemical formulas, chemical equations. But for today, mutakopali tuachie hapo. And I would like to say this. There are people who are coming for... My office is in Limuru. Let me tell you this. That my office is in Limuru. Apart from teaching online, I also sell exams for revision. There are people who come here. Now let me tell you this. There are people who come to our office. They pick exams like for all the subjects that you menafanya. I work with many teachers from my school and outside my school, even for PP1, PP2, CPC and all those. So someone comes and let me use a subject I teach like like physics. You come and pick one exam ya physics, you go and do it, ukimaliza unanirudishia na kumakia. When it is done, unapikiwa simu, unakujia. That is for the people who are in Kiambu. Now, somebody who's in Nairobi, how do we do it? You just contact me through this number so that you request for the exams that you want. Kama ni ya maths, niambie nataka exam ya maths 0796 26 24 71. So this is the number for Sir Alex. Or for our office 074. Pengine ndakuwa nimefly out of the country. My office secretary can help you 0740 61 90 25. Kazi yako tu ni kuitisha exam. You tell your mom or dad to pay for it. Then after that, uende ufanye. If we can mark for you, you utulete. If you want another teacher from another school to mark for you, we will still appreciate. But visit our offices. Ukifika Limuru town, ulizia Ketias iko wapi. Ketias, then uliza kwa ambassador ni wapi. You will get in, unasema nataka mtihani hii na hii na hii na hii na hii, upewe, uende ufanye, ukimaliza utulete. Tukumakie, tukuandikie recommendation. Do this, do this, do this. Then that's what we are doing during this particular holiday. I want to thank you for joining me this afternoon. I'm just imagining ninge join lesson. Nijipata I'm alone teaching here together with my producer on the other side of the camera. Si ingekuwa kitu mbaya sana. So, you know, I'm just grateful for you. Tomorrow the same time from 3 tutamalizia topic. We shall be analyzing the periodic table. The problem nyinyi amutaki kufanya nini? Amutaki kuinvite wengine tufurahie lessons pamoja. Bernard Mwai unasema Beverly usisahau 2P. 2P iko na nini Bernard Mwai? 2P tiko sawa. Kuna mtu anawasumbua anaitwa Amy. Anauliza which school. Amejibiwa pale juu ameambiwa Kotet ama Loreto Limuru. Bado anaandika which school is that. Hatuna shule wewe, hatuna shule sisi. Our school doesn't have a name. Yes. Otherwise, allow my producer to end the live streaming. God bless you.